Today we are going to be taking a look at this, the ToolkitRC M7AC charger. Now I actually released a review of this charger a few weeks ago on the channel, but then took it back down. The reason I did that was after releasing the video, Wheelie Bloke reached out to me and asked if I was seeing an issue with it. He provided me info and I did some more testing, and it was clear that my charger also had the same problem. The reality is I had actually missed this issue in my original testing, and as a result of that, it was not right for me to leave the video up. Since then, ToolkitRC have resolved the issue. They have sent me a new charger, and today I am going to review that new charger. I just want to be clear, ToolkitRC have sent me this charger for free. However, they have not seen this video before it's been published, and as always, my thoughts are entirely my own. As I understand it, with regards to the issue, it was only on the sample model set out, and I'm going to explain a bit more about that issue later on in my overview at the end of this video. Anyway, let's get on with it. Let's take a closer look at the charger first of all, and then I will share with you my final thoughts. The M7AC from ToolkitRC is a multifunctional single battery charger. It supports a DC input of up to 300 watts via an XT60, AC input via the mains of up to 100 watts, and it is what they class as multifunction because it's a charger, discharger, but it also has some additional functionality like the ability to actually play back voices, test servos, and even charge DJI style batteries. Now, if we flip over to the back of the box, here you can see the main specification. It supports all of the usual battery types, which is Lipo, Lipo high voltage, Life, lithium ion, 1 to 6S. It supports nickel metal hydrides, 1 to 12S, as well as PB or lead acid batteries up to 10S. It can charge up to a maximum of 300 watts on DC, as I've said, or 15 amps, and on AC, again, up to 15 amps, 100 watts. It can also, though, discharge, and it has the capability internally of discharging 15 watts max via the transistors, but it can also discharge via the recycle or external option up to 300 watts as well, allowing you to put that power back into another battery. It has a 2.4-inch 240 by 320 LCD display, and it also has a USB port which is 5 volt up to 2.1 amp max, and it's also got an SD card slot on the side as well for uploading some voices and things like that. If we flip it over and take a look inside the box, the first thing you'll find is the main charger itself, and then the instruction book. If we then flip that over here, you'll then find a power cable and a USB cable for updating the firmware. Walking you around the main charger, on the front we have our LCD screen. We have a nice metal roll wheel which scrolls either side, as well as has a push button in the centre, and then we've got a single button here which is called Exit-F. If we flip around to the front, you can see our main I/O. So we have the 5 volt 1.2 amp USB port, we have servo ports, 2 to 6S battery input for our balance port, and then we have our voltage output, which is either XT30 on this side, or you can slide the cover across to reveal the XT60. If we then move around to the back, you can find the DC input, which is XT60, and then the AC input over the other side for our mains cable, which is a typical figure of 8. We've then got our on and off switch and the power then in the center. If we move around to this side here, you can see there's a speaker there, as well as the micro SD, or what they call TF, transflash card slot here, and that's used for uploading voices and other things onto the charger. If we move over to the back, you can see there's a little flip up stand with some rubber feet, and then on the side here, you've just got a metal plate which has the ToolkitRC logo. Now, to demonstrate the charger, we're going to use a DC source today, and I'm going to use a 4S Lipo. The input range on the DC source of this is 7 to 28 volts, up to 20 amp max, but you do need to make sure that you don't go over that 28 volt input range. So what we'll do is we'll take our Lipo and plug it in. We'll then wait for the charger to power up, and then you can see it's taken us to the main screen. Now on here, it shows you various pieces of info. We have our battery voltage, the watt hour that has come from our battery voltage on the input, the internal temperature, and then down the bottom here, it's got all of the usual info for our battery output for charging. If I now take another pack and plug it into our DC output on the front, and then also plug this into our balance port, you will then see things come to life down here. You can now see we have our battery voltage, and then we have our individual cell voltage down here listed below. I can also scroll across, and if it was charging, it would show us other information such as the internal resistance of the batteries. Now, to access the main menu on this charger, you simply press the center button and that brings us into the main screen. You can see we have the battery type option at the top. So if I select on that, we can select the type, whether it be Lipo, Lipo HV, Life, and all of the usual options that are available to us. And at the bottom, there's also an interesting option called UAV battery, meaning you can even charge it with things such as the DJI Phantom 3 or Phantom 4 batteries. So we're going to select Lipo. We've then got the option to select the cells, whether we have it in auto or manually up to 6S. We've got the mode, whether we want it to charge, discharge, or storage charge. We're going to select charge. We've got the chosen end voltage. So again, we can adjust that depending on what battery voltage we actually want. We've got the maximum charge current. So again, we can set that all the way up to 15 amp and all the way down to 0.1 amp. So we're going to set that at 1 amp for the purpose of this. And then you've got the option to start the charge. If I press that, it then gives us a second confirmation. Click OK, and you can now see that the charger has actually begun to charge the battery. And what we're doing now is charging from the one Lipo to the other. Now that's up, you can now see that there's a bit more information along the bottom. We have our individual cell voltages with each one flickering as it's doing balancing as it's charging. If I scroll across, it's got the internal resistance of each cell. And if I scroll across again, it's giving us a bit more information such as the charge wattage. If I then press the menu button again, we have the option to set the current, so we can change it whilst in charge, or we can tell it to actually stop charging, and then the charging stops. There are also other options on this charger. If we press and hold the exit F button, this will bring up the main system menu for the charger. Under here, we have things such as measure resistance, measure signal, signal output, ESC test, power, and this allows us to do some of the extra functionality on the charger. So for instance, if I click on power, we have the option of using it as just a power supply rather than a charger. So it would take our DC input there, and then we can select what output voltage we want, set at 0.1 volt increments, and then we can set the maximum current and then hit start, and then that will set that on the main output. The other functionality under here allows us to do things such as measure resistance. We can measure signals. So again, we can measure the signal via those signal input ports down here on the bottom. And if we scroll across, we can see we can measure PPM, S-bus, all of the usual typical RC functionality. We then have signal output. So rather than measure the input, we can actually use this to test servos, whether it be PPM or S-bus on the channels as well. There's even an option here to test the ESC as well. Now, overall, the charger has all of the usual functionality you would come to expect on a modern charger. Next, what we're going to do is take it apart and we'll take a closer look at how well it's made. Okay, so I've taken the screws out and we can now go inside. Now, I've already had a quick look at this and it appears that you hinge the lid up like this here to reveal the inside of the unit. And we're sort of hinging on this adhesive plate here, which I'm going to unstick. But what we do have is a ribbon cable in there going from the main board to the display. So what I'm going to do is gently flip that up and disconnect that one. And then I think what we'll do is give this a bit of a tug, which should then allow the adhesive to come free and give us access to that panel. Okay, I ended up using a little bit of heat on the sticker just to release the adhesive. So here you can now see the inside of the main top PCB. We have our little roller over here, and this is quite interesting. This actually just comes out. So it slots in to this little rotary encoder on this side here. And then there's the push button there that it presses on. And then in the lid, there's like a groove that holds it in place. And that is a fully machined metal wheel as well. Now on the top here, we can see the inside of the board. Now there's quite a lot going on in here. We have what appears to be a board over here on top, or actually that's not on top of that board. That's next to it because it's cut out. So that looks to be our AC board, our AC input. And then this side is our DC and charger side with our fan down here. So what I think we'll do is undo some screws. We'll get this board out. Okay, that's that screw released. And we'll see what happens now. We'll see if we can lift that up. What we can do probably is lift out our metal panel on the side. Look, that's the ToolkitRC name badge. I believe they actually make them in different names as well. So you can actually get different versions. The fan will lift out there as well. Okay, that's come out there too. We've got a couple of screws here. But looking at this, the AC side definitely needs to come up first. And what it looks like is the AC side's DC output then comes down to this main board here. And that is what's giving us our main input to the supply. But at the moment, I can't actually see a way of this board lifting out. Okay, there we go. Gave it a bit of a push on the connector. And then the board actually lifted up. So we can now withdraw the AC board. You can see that it looks like that they've added a capacitor on here. There's one underneath. You can see directly below it. And that seems to have been put on as an addition. And then if I withdraw that out, you can then see the DC board comes out. So what I'll do is just flip this over so you guys can see the AC board. We've actually got two boards on this. We've got the main PCB with the capacitors. There's a little heat sink there, look, on top of the transformer. Quite interesting. We've got some capacitors along here. We've then got the rest of the circuit down there. Let me just flip it that way so you can see it. There we go. You've got the rest of the circuit there. All done very, very compact indeed. Very, very compact. And then you can see on this side of the board, as we showed on the top, we've then got the various... You've got an IC, we've got some transistors, all part of the switching circuit to provide the output from the supply. And then you can see that there's, looking at this, there's three outputs. So you've got VCC plus, 12 volt and ground. I don't know what VCC plus is. We don't know what the voltage of that is. And then that goes down to the main board on that area there. I think what we'll do next is just get the screw out of that main board and we'll lift that out and have a look at what we find on the other side of that one. Okay, so just lifting out the main DC side of the board. And then again here, you can see we have our heatsink, which appears to be on the back side of the board. I can't quite... Oh no, is there anything under that? I don't really want to remove it. Oh yeah, there is ICs under it. I can see there is some stuff under that. So I'm guessing we got some something under there. I don't exactly know what. And then you can see our capacitors. You can see our fan header down here. Our DC output. Sorry, our DC input, I should say. Our two DC outputs. And then we've got our other ports along here on this PCB. There's a whole range of headers down there not used. And then again, if we flip over to the back side of this board, you can see that we have all the other circuitry. We have a microcontroller, which is labeled ARM. So I'm Cyclone Devices, I think. I'll try and zoom into that and put a picture of it up on the display so you guys can see it. Not sure exactly what it says at the moment, but we'll take a closer look at that in a second. Then we've just got the rest of the circuitry with our rotary encoder board screwed on the top. Now, just looking at the quality of the build, I have to say, overall, the PCB does look decent. The soldering looks good. I see nothing here that raises any concerns at all. There is an awful lot going on in here, actually. Considering it is basically just a charger, you can see that there is a lot. We've got the main microcontroller there. We've got our balance resistors. You can see them there in that little row there, most likely. That'll be the balance resistors. We've got capacitors on the board all down here. You've got some additional circuitry. Another regulator over here. And then if we flip it over on this side, we've got our capacitors. We've got 35 volt 470. Rubicon from the looks of it. You've got choke, inductor. And then we've got under this heatsink I'm guessing is the switching FETs, or maybe resistor bank for balancing. It's hard to actually say what is under here. Interestingly, that might unscrew. Shall we have a look? Okay, so there we go. Ah, there we are. That's what we were missing. There is everything else. Right, there is our balance resistors. I thought they looked a bit small. So here is the row of balance resistors for the balance port over here. We've got a shunt resistor there. You've got your FETs over here as well for the switching. So there we've got the main area of the board that is going to be producing the heat. And then that's obviously mounted to this heatsink with a thermal pad on there. And then that's screwed in place with the screws I've just removed. As you can see, you've got the transistors that go to the resistor bank. So that allows it to control the balancing port on the unit. And yeah, overall, everything looks pretty good. Okay, so there's a closer look at the SoC in this. It is what is known as a GD32F303 by Giga Devices, and it's got an ARM logo on it as well. If we then just take a look around the rest of the board, you've got some other ICs. I'm not exactly sure what these are. These are labeled HC4052s. We've then got something else there, which is a 600. Can't quite see that there very easily. You've got Fortier FD6288Q, whatever that is. And just trying to look what else. There was some smaller ICs. Oh, that might have been on the other side of the board. So let me just flip that over. There we go. We can see the balance resistors there. And then you've got the transistors for them. And then you've just got the FETs over here. And that's the part numbers on the FET, so you can see them. And then if we just hop over to the AC board, just to give you a look at that. Again, see some flux residue on the board, some FETs. AC board does look a little bit rougher than the DC, if I'm honest. The DC board looks a bit better made. You can see that additional capacitor there. It's not bad, but it just looks a little bit messier, if I'm honest. But it is also coated, so it could be the coating that's doing that. But again, see there all the resistors and everything. But the soldering looks decent. There's nothing there I'm concerned about. Just looking around, just want to look at that cap. Yeah, he is soldered. Yeah, there's nothing I'm particularly worried about. Okay, so it's all back together. I'm just about to put the lid on. Lastly, I just really wanted to discuss what I think. Internally, it all looks good. The only real thing is they've clearly added this capacitor as an extra. I don't really feel it's a problem the way it's been done. I think it looks like they want a bigger value, but they can't do that with the space they've got on the board. So instead of doing that, they've got one on the side here and one on the bottom. But it's not badly done. It's absolutely fine. It's not going to break off. It's not really going to get damaged by anything. There's space above it to here. Other than that, though, the overall build looks decent. The AC board doesn't quite look as tidy as the DC board. And I do wonder if they're actually made at different factories. I do wonder if that's the case. You can see that there's like a name down here. I've not seen that on this board. They look similar. The PCBs are basically the same. It looks the same color, but it just feels that the components on this board, some stuff isn't quite straight. You can see that here, you can see that there, and just there's a feel to this board not quite being as tidy as the bottom one, but there's certainly nothing here that's going to cause problems. It's absolutely fine. Okay, so it's time for me to share with you my thoughts on the M7AC from ToolkitRC, but before I do that, I want to explain a bit more about what happened with the original review. When the charger came in, I did my initial load testing on AC, so we tested up to 100 watts in DC power supply mode, and then I did the same on 300 watts on the DC side, and then did all of my testing of the charger on DC. The reason for that was my bench setup is set up as a DC bench, in the sense I have a couple of lead acid batteries that I use for charging and discharging into, and the way I was doing my tests was simply to make sure that the charger was capable of outputting what it should have and how it behaved and performed, and that was simply done as a matter of pure circumstance on the DC input rather than the AC. Whilst my initial tests absolutely passed on the AC input at 100 watts, the problem was that it would stop charging after 20 to 30 seconds on the AC input, but would work absolutely fine on the DC input. As a result of that, I missed that fault, and Whirly Bloke, who I want to say a massive thank you to, was the person who reached out to me and said, hey, I've seen your review. Are you having this problem? Because I am, but you don't appear to be. The reality was I missed it. That will not happen again. And in future reviews, we will be doing full testing on AC and DC and not just load testing on either side, because that way I will make sure that we don't miss any issues like this in the future. Just to be clear, I had done all of the testing on the DC side that you would have expected me to do, charging various batteries of different cell counts at different capacities at different loads. It was fine. What I didn't do was replicate that on the AC side. I simply just load tested to 100 watts to ensure that the AC side was capable of providing the specification that the manufacturer said it will. So, do I recommend the M7AC from ToolkitRC? And the answer to that is actually yes. I found this charger super handy before I realized I actually had an issue with it. The fact that it is a DC 300 watt charger makes it a really good portable charger for me. The fact that it supports 100 watt on AC, 300 watt on DC is handy. You can use both. It has the capability of charging normal Lipos. You can charge some of the DJI batteries as well. And you have that extra functionality such as power supply and the testing for servos and inputs too. This has predominantly been in my bag for the last few weeks, and it's been the charger I use when I'm out in the field. But if you're someone that's looking for a portable charger, it is one I would consider, because you do have that AC input as well. So if you're out and about and you're using a car or something like that to charge, you can use the DC or a larger Lipo. But if you're in somewhere where you want to be able to use mains, you can do so too. Now, if you have found this video useful, please do consider checking out the link to my Patreon. I want to say a massive thank you to all of the support my Patreons give. I would not be able to make the independent content that I do without the support of my Patrons, and I would not be able to be as open, as honest as I am without fear of what the manufacturer may think without the support of you. So I want to say a massive thank you to all of my Patrons, and if you think I have earned your support, please do consider checking it out. Anyway, that's it from me. There's a link to it in the description. Please do stay safe, and I will speak to you soon.